So today we are going to talk about object-oriented programming concept, right? Our whole objective and the course is Java plus Selenium and other things related to automation side. But as of now, we are learning object-oriented concept. Some of the concept I have already covered in some of the previous session, right? But the major things about encapsulation, polymorphism, right? Some other concepts are still not done. So today we'll talk about overall thing on the object-oriented programming thing, and encapsulation. We will see the example. Right? But before that, what is object-oriented programming itself, right? So if you want to learn that, there is a good tutorial available in Java T Point about the object-oriented programming. I am not going into jargon part of it. I am not going into what is the definition of it, right? I want to cover actually what it is. Okay, so let's understand first of all, when we say object-oriented programming, what it is. Object-oriented programming means you are doing something which is related to real world entity. Okay. Your program, your functions, your data is all about some kind of object. Now your question is, okay, what is real world entity then? What are the things we can say real world entity? So the thing is, anything which you can generalize, generally they are real world entity. So for example, maybe some examples are here. Here, it's like, fine, two-wheeler or the vehicle may be an object, right? Table is object, fan is object. Whatever you are seeing here, this is not just limited to this. Why we are saying this? These are objects because, or the entities, right? Because all these things will have their own some properties or the types, correct? And some functions which are associated with it. So for example, bike or the vehicle will always have some kind of how many wheels are there, right? Some functions related to acceleration, some function related to brake mechanism, right? In the same way, pen will always have, let's say, some ink color, its height, its width, right? Lot of things. I'm giving just simple example. Now the question is, why we need to program it, or why we want to think in object oriented way? Because when you are making a software, you are playing with the objects most of the times. So why not create your program in such a way that it will be bind together, their data and the method will work hand in hand with each other. It's like this. Okay, so object means real world entities such as these examples. And object-oriented programming is methodology or paradigm to design a program using class and object. It simplifies software development and maintenance by providing some concepts. Then there are some concepts, invented, let's say, around objects. Class, object itself is a concept. Inheritance, polymorphism, abstraction, encapsulation. If somebody asks you, hey, what are the object-oriented programming, principles or the main entities related to OOPS? So you can say object, class, inheritance, polymorphism, abstraction, and encapsulation. These are the basic things which should be there in a programming language. Then we will say, okay, it's an object-oriented program. Okay, so Java is one such object-oriented program. That's why you must have observed that Whenever we are working in a Java program, we always, put some kind of class first, right? We make the class, then it works. But significance of object and class is interrelated, right? We will see that example in a minute, right? I just want to go through some pictures so that you will understand that, what we are doing. Apart from this concept, there are some other terms which are used in object-oriented design: coupling, cohesion, association, aggregation, composition. Generally, we are doing all these things without knowing, how it is, how it works, but we are automatically, using it. Don't worry about it. Okay, fine. This is just a picture that there are different object-oriented programming parts. Objects, we already talked about. Class. By definition, it is collection of object is called class. It's a logical entity. Class can also be defined as a blueprint, which you can create an individual, from which you can create individual object. Class doesn't consume any space. Basically, this concept I have already defined in one of my previous session when we talked about classes and object already. But I am here just telling you again that class, when we say class, any class, so you are defining it. Okay, class name is, let's assume the class name is car. Let's assume car. Okay, and you will be having some properties. So for example, let's assume that color is a property. Color is some kind of property. Or another property may be max speed. Okay, or model, or the make. It's something like that. Just that's it as of now. This is class. But how you create the object? You write class. Let's say the name of the object is C1. You can give any name. Is equals to new, means class name. It's not class. Here it will be, I'm talking about the syntax part of it. Class name C1 is equals to new class name. So here, because the class name is car, right? What you will be writing? You will write car C1 is equals to new car. You will be writing like that, correct? So let's write it. You will be writing car C1 is equals to new car. Okay. What happens behind the picture is, when you declare car C1 is equals to new car, what it does? It creates or reserves a memory space, right? Where color, max speed, and model will go with this object. What it will go? So color, whatever are the properties, max speed and model. Here it will be C1. So what we say? New car. Whenever you are saying, using the word new, it will create a new template, a new object, right? Not the template. Template is this. Class is a template. It's a kind of mold which you have to do just one time. But whenever you want to create the copy of this, you have to write new car. Okay, so new car, what it will do? It will check, okay, what are the class level properties are there, right? Or the instance variable are there. Let's put it in a box with default value. There is no value here. Color value we will fill later on. And the reference will be C1. So what kind of object it is? The type of the car is, type of the object is car. It's like this. It's like in another way, in simple words, you are binding the data types together. So for example, this color can be the string, maybe, possibly, right? This max speed may be an integer value, it's possible. This model may be again some kind of, let's say, string. Okay. Now, because these are three different variables, right? Every time, you know, you cannot have, different kind of variable for a car. There are generalized properties. So car will always have color, a car will always have max speed, a car will have a model or the make, correct? That's why we can say it's a general, it's a real world entity, as well as if you want to implement it in object oriented programming, we can implement it easily, right? What you have to do, you have to say car C1 is equals to new car. So whenever you will create a new reference to the new object here, C1 will be created with these things. Then if you want to fill the values, you can say C1 dot color is equals to something, right? So here, let's say, I'll say red, something like that. And then C1 dot max speed, C1 dot model, that is how it works. Fine. You can make as many objects. You can say car C2 is equals to new car C3 is equals to new car. You can create multiple objects here. Okay. Going back to that. So that's why we are saying class is just blueprint. Class is a kind of blueprint only. And then you create multiple things with the same kind of thing. It's like you are making a Word document. You create a document and then you are printing it as many times. You are printing the same thing as many times, right? But you can make changes on that. You can make changes on, some of the properties. It's like this. Okay. Inheritance, we have seen it. Polymorphism, still we have to see. Our topic today is encapsulation. So encapsulation by definition is, they say, wrapping up the code and data together into a single unit. It is called encapsulation by definition. But actually we have to see what does this mean. Okay. We don't have to just go by the definition that this is this, this is this. Okay. We should understand that actually what they are saying. Right. So you can check this one also as a good chapter here about the encapsulation. So encapsulation, make sure that sensitive data is hidden from the user. To achieve this, you must decide class level variable as private, public, provide public get set method to access and update the value of private variable. Okay, so we'll see that example, what it is saying. So basic part to implement encapsulation is, two things. You should provide your variables properly with, you have to declare your class level variable with properly what is their access specifier, whether they are private or public and all. It's better you declare it private so that it will be the property of that class only, right? Its own property. Right? But then if somebody want to get and set those value, we will not restrict them. We will not say, no, you cannot get those values because it is private, or you cannot set the value. It's not like that. What we can do is we can create our own get and set method, which will work with those variables. It's very simple. And that is what encapsulation is basically. Okay. I am just copying this and I'll make you understand what it is. And it's a very simple thing. This is a very simple example about a class person. Let's create a new class. Right click, new class, person. That's it. And I'll not create main function as of now. I'll finish it here. Now let's understand. Here we are saying there is a class person. Okay. We are saying that we will have a property as name. Okay. And it will be string. So this is like declaring a class level variable and saying that, hey, this class will have property. One of the property is name. There may be other properties also like height, nationality, lot of things, right? Whatever you can think about a person, right? That gender, age, lot of things. As of now, we are declaring just, let's say, name. Now, you must have heard about getter and setter method. And this is the getter and setter. What it does is, it says that, hey, don't play directly with this. So what I'm saying is, here, we are assigning the value, right? C1 dot color. In future, somebody can do C1 dot color, they can change the value. They will say C1 dot color is equals to yellow, right? And they don't know, like, they may try without knowing whether it's a public property or the private property, correct? So it's better that you declare it private and have the getter and setter method to do the things what anybody want to do. Okay, instead of doing it explicitly in this way. Okay, so this is the systematic approach to perform whenever somebody want, what is the current value of their own properties, right? So what we are saying, public string get name. So this function is we are creating it. It's not like it's provided by the Java. You as a programmer, you can write get name. What it will do, it will just return the name, right? This will make sense. Just wait for 2 minutes. Public void set name. So whatever value will be passed, that will be set for that particular object. What I'm saying, let's create a main function. Okay, so we say public, or in any other class also you can create main function and you can create the object of this class person. Public static void main. This is the way we create the main function, and actually the execution starts with main function. Okay. In Java program, what happens is whatever you can write, but actual execution starts from the main function. Here, how I'll create the object, I'll say person P1 is equals to new person. Here, P1 is a kind of object reference only. Okay. As I said, what will happen in the background, P1 will have, so let me write it. So can I write P1 dot name? It's showing me that there is a property name. Okay. But can I do that thing? P1 name is equals to, can I say here, Nitesh, let's say. Okay. Let's do that. And I will say system.out.println the value P1 dot name. So I have set it and now I want to print it. It's very simple program. I have set it and now I want to print the same thing. Okay. If I'll run this, this will say that, okay, let's run this. It's printing me Nitesh, right? But here, when you are checking this, basically, right, you are explicitly doing it, right? Whereas the ideal way is, do it through getter and setter function. So that every class, if you want to set a particular property, right, you can do it through their own getter and setter for each and every variable. or each and every what we say class level variables, and this function is encapsulated with this variable. That's why this is called encapsulation. Means this getter and setter functions are actually working on these variables, right? That's why we say data and method work together. That is called encapsulation, right? In simple words. Okay. But then what I am saying, so can we do it like this? Instead of putting it, I'll say p1 dot. Can I say set name? And the name I'll pass the name. So let's say I will say p1 dot set name QA testology. Okay. And here, let's print it. So what I will say, I'll say p1 dot get name. Instead of saying I want to print explicitly a particular variable, why you want to remember it, right? The thing is, you don't have to say explicitly I want to get this particular thing. The thing is, you should get it through the function, because even if it is a private property, you will be able to get it. Okay, even if it is a private property about the name, you will be able to get it. Here what we are doing, we are overwriting it. Means earlier the name was Nitesh, but then I said, set the name as this now. So basically p1 dot name is now QA testology. Okay, get name is, instead of writing p1 dot name, we are saying p1 dot get name. So remember that in interview, if somebody asks you what you achieve through get and getter and setter, so you can say a basic concept of encapsulation. Or if somebody asks you how to implement encapsulation, so you can say whenever there are data and the methods in a particular class, we can write getter and setter method to achieve basic level of encapsulation. Okay, that's it. So the get method returns the value of the variable name. So this we already talked about these things. Okay. However, as the name variable is declared as private, we cannot access it outside the class. So what it is saying, that this class you have created, perfectly fine. But can I do the same thing in another class? Let's create another class. Let's do one more class here. I'm giving just, I'm saying, let's say test encap, any random name I'm giving. Okay. And I'll create main function. And what I will do here, I'll show both the classes. Wait, what I will do, it's possible to do that. Yes. So this is person class and this is test class, which we are making now. Here, what we will do, we'll say same thing, person P2, let's say a new person, is equals to new person. Okay. And now here, can I say P2 dot name? No, it's not coming. If you see here, I am not able to get this P2 dot name. No options are coming here. Why? Because name is the private property of this class person. So you cannot say P2 dot name. If it is public, you will be able to do it. If I'll make it public, you will be able to do P2 dot name is equals to some name, right? But it's private, so you cannot do it. So how you can do it? Instead of that, you can say P2 dot set name. Okay. Because these data and method are automatically binded together. Okay, so the other class do not have to worry about what what are the variable name, whatever you want to set it. It's like this. So here I will say p2 dot set name is equals to John. Okay. And then if I want to get the things, I can simply say p2 dot get name. So P1 and P2 are independent. P1 and P2 both are independent. P1 which you have created will have its own, here if you see, you created C1, it will be separate. If you create C2, it will be again a new box. Okay, it's like this. So P1 person P1 do not know that there is a person P2 also exists. Okay, both are totally different, but still same in a kind of different common properties. It's able to print John. So this is how a basic level of encapsulation is achieved. By default, there is a problem. Means it's not like that you are doing something new thing here. It's like data and the methods are bind together. That is called encapsulation in simple words. Okay. That's it about encapsulation. We are going to see more examples now.